Morning to one and all. Today, we are going to see about the approximations in modeling or basic assumptions in the fault analysis. So what are the approximations we are going to um, model in our fault analysis? So these are the some of the approximations that made in the fault analysis. First, representing each machine by a constant voltage source behind a proper reactance, which may be X double dash, that is subtransient reactance. Next, X dash transient reactance, or X steady state reactance. See what are all the machines given in the single line system. For all machines, you need to make a reactance. You need to make a proper reactance, or you need to make a proper impedance. Okay, for that particular equipment. So what all the equipments connected in a bus, you need to make the proper reactance or impedance. So that might be indicated by X double dash for subtransient reactance, X dash for transient reactance, and X for steady state reactance. So that you need to remember. Next, pre-fault load currents are neglected. Pre-fault load currents, say for example, what is the previous load current? Okay, say for example, you are analyzing a system. So previous load currents are to be neglected. That you need to consider. Next, transformer taps are assumed to be nominal. So the taps of the transformers are assumed to be a nominal value. That is some ideal value, nominal value that you need to consider. Next, shunt elements in the transformer model that account for magnetizing current and core losses are neglected. So shunt elements, say for example, if you take the equivalent circuit of the transformer, there are some shunt elements also there in the transformer model. So that accounts for magnetizing current and core losses are to be neglected. Next, a symmetric three-phase power system is considered. Okay, always a symmetric three-phase power system is considered always. Next, shunt capacitance of the transmission lines are ignored. So if shunt capacitance is there in the transmission line, that ought to be neglected or ignored. Next, series resistance of transmission lines are neglected. So already you modeled this kind of thing in your pi transformation and T transformation. In that, you will be having shunt capacitance in the transmission line, series resistance in the transmission line. So that kind of things should be neglected in the transmission lines. Next, the negative sequence impedance of alternators are assumed to be same as that of the positive sequence impedance. That is, Z plus is equal to Z minus. That is, so what all the negative sequence impedance in the alternator, that should be the same as to the positive sequence impedance. So these are the some of the approximations that to be made in or assumptions to be made in the fault analysis. While doing the fault analysis, these are the assumptions to be made. So this is one of the important 2-mark questions repeatedly asked in your semester examination. So without this, you don't go for, if you are studying a particular unit fault analysis. So first you need to study this approximation of the or assumptions in fault analysis as a first 2-mark question. So